Use those equations that were just established. We figure out what we know and then what we're looking for, and then just go back to those equations and figure out which one we would use. So some of the things that we would use here include, just from this picture, so you a lot of times want your lowest corner here to be the origin. Okay, so this is our y naught would be 150. Okay, so that would be one thing that we would know. Our initial position would be equal to 0. Okay. And then the 180 we have to split into its x and y components by just taking the trig there. So then 180 cosine of 30 would be our p naught x, and the 180 sine of 30 would be our p naught y. Okay. And then this over here would be our x, and our y being our final position. Remember, the little sub-zero there means the initial. And so our final position would just be some random number x and y. We know one of these. Which one do we know?
Y.
Yes. So this would be at some unknown value x, and y is equal to 0. Okay, so I can already tell you what they're going to ask for. They're going to ask for the horizontal distance, and then actually they also want to know what this greatest elevation is. Okay. So hopefully that picture doesn't move. Yeah, and I guess one more thing that I could put on there is that ax is equal to 0 and ay is equal to negative 9.81. And then you just pull these equations in. Okay, so look at these and say, okay, what can I use to solve for something? So which one of these can we use to solve for something? We said we knew y, correct? Okay, so we actually know that this is 0. Okay, so we can solve for t there. And then once we know t, we can solve, what are we looking for? We're looking for the x component. So they'll probably have some more equations here. Okay, so once we know t, then we can plug that time. We know time, we know v naught x, which is the 180 cosine of 30, and then we can solve for x.